My name is Tim. I've been with the Kubernetes project more or less since the beginning, since about mid-2013, before we open sourced it. I'm responsible mostly for infrastructure problems, networking and storage and those sorts of things. But I've been around the project for a long time, so I've sort of experienced a whole bunch of different topics. And today, when we're getting prepared for this, I sort of said that I've got a bunch of topics that I sort of got some material on that I'd love to talk about. And this is the one that the organizers thought might be fun. So I'm going to talk about extensibility. What do I mean by extensibility? I mean how you think about Kubernetes as a building block for the rest of your solution. Kubernetes is just a piece of anybody's solution. So when you talk about Kubernetes, you ask different people, what is it? What is it for? Well, it's for scheduling containers. It's for doing this. It's for doing that. I want to focus on two answers. One, it's an abstraction layer over cloud infrastructure, right? You get to decouple yourself from the details of your infrastructure, which I called out, and I think that's a great way for people to use Kubernetes. It helps you to be portable. But there's another thing that Kubernetes does that's a little less well known. Kubernetes is a framework for declarative APIs. What? This is the sort of thing that if you try to do on purpose, you'll always fail. But if you do it accidentally, it turns out it's great. So what we did with Kubernetes is we defined this API framework that runs our servers and our resources and our control loops. And when people looked at it, they liked it. They liked the pattern. And they wanted to use it themselves. They wanted to emulate the pattern that we had built with our APIs. And so I'm going to talk a little bit more about how we can do that. So depending on your perspective, and most of my perspective is in the infrastructure space, depending on what your perspective is, where you're coming from, you have a different need out of Kubernetes. If you see it as an abstraction for your infrastructure, you are looking for extensibility of that infrastructure. If you see it as an API framework, obviously you want API extensions. And these things have different goals, different purposes. If you're looking for infrastructure, if you're taking an infrastructure perspective, you want portability. You want your Kubernetes installations to be portable and abstract. You don't want to be coupled to your infrastructure. Anybody who's ever sent me a pull request knows that I am a bottleneck of the project. So extensibility for the last time, I see people laughing. For the last 2 years, we have made extensibility a major focus of the project. All up and down the stack, we have focused on making it possible to extend the system without modifying the system. We've got probably a dozen different ways within the system to do this. I'm going to talk about just a couple tonight. And there's more, if you want to go, you can follow along at this link here and read more about some of the extensibility. And I'll post these slides afterwards too. So let's start with infrastructure, which is my sweet spot. So when we think about infrastructure, these are the sorts of things we think about, right? These are the things that are underneath your platform, right? And you want to make sure that you're providing an even, flat surface for your developers to work against. If your developers know that they're running on Amazon, then they might as well not be running on Kubernetes because they're locked in Amazon. If they know that you're running on Google, you might as well not be running on Kubernetes because you're locked in Google. We want these applications to be portable. We want you to be able to pick up your YAML and take it to somewhere else and drop it in and have a good experience. So we needed to allow people to replace these components. We needed to provide storage drivers and networking drivers and cloud drivers without sending Kubernetes changes. There's other stuff too that you want the cluster operator, as the sysadmin of your cluster, you want to be able to replace. That's even things like the container runtime, like Docker, right? Or the auth systems, or how you do scheduling. All of these things are replaceable in a running cluster. I never experienced two that work quite the same way. So there's no one size fits all. There's no solution that works for everybody in all networks. It's very difficult. Kubernetes takes a pretty opinionated position on what it means to be a Kubernetes compatible network. We've got some documentation on the Kubernetes network model and IP per pod ethos. We needed a way for users to be able to tweak and configure how is Kubernetes going to set up the networking underneath the cluster. So we came up with a plugin format. It's called CNI, the Container Network Interface. It was started by a company called CoreOS, you might have heard of it. It's now been donated to CNCF. And it is a plugin standard that is, it's over in exec. So we run a binary, we get some command lines, it goes out and configures the network for your pods, and then it comes back and tells us what it did. And what it does now is it allows us to work with vendors who can provide their own binaries without talking to, without sending me a change, and they can go out to your users and they can ship their binaries. Now you can configure your cluster to run with arbitrary network equipment, or if you're a highly polished system, you can go off and do your own thing, right? You can take other drivers and hack them together. There's a lot of open source drivers that implement this interface now. What's super cool is because it's a plugin interface, it's now used by other projects. So the Mesos project, you may have heard of it, also uses CNI. So now you can take the same network infrastructure and run it across these different environments, and you get the same experience. I thought this was pretty cool. The vendor uptake has been great. We have a couple of vendors who are selling or building their businesses exclusively around Kubernetes, and we have a few old traditionals like Cisco who are shipping their drivers to work with the Cisco equipment with Kubernetes clusters. Pretty neat. So the best friend of networking is always storage. There are so many storage technologies out there that it's impossible for us to possibly have drivers for all of them. And what's, again, super cool, in the cloud-native world, there's all these companies that are being formed to make new technologies, new storage technologies, new networking technologies. It's amazing. Now, there's also things like virtual block file systems, NFS, you've got your classic Isilon systems and NetApps, you've got your giant EMC systems, and they all sort of work differently. There's a whole bunch of sort of standard protocols like Fiber Channel and iSCSI, but there's also these custom things that people are putting out, like Portworx, and Gluster, and Ceph, and some of them are open source and some of them are not open source. We wanted to integrate. We had all these vendors who were coming to us saying they want to integrate with us. It was one of the earliest bits of extensibility in Kubernetes, in fact. So we started with version 1. We had the built-in plugins version. It was known as Send Tim a PR. It didn't work too well. We have about 15 plugins that still operate this way. Then we adapted a new interface called Flex, which allows you sort of like CNI to write an exec plugin. More recently, we've been working on a new plugin standard, the CSI, the Container Storage Interface. You might see a pattern here, which is actually set to go 1.0 very soon. This is a new plugin interface that took some of the learnings that we'd had around Kubernetes and plugins in the intermediate year. It's a collaboration. It is a group effort between Kubernetes, Docker, Mesos, and Cloud Foundry to produce a universal storage driver interface so that all the vendors can produce one driver that works across all of these systems, because this was a major pain point for them. Question?
Yeah, what was first? Storage interface or network interface? What was first?
The question is, what was first? The volume drivers, storage drivers, were one of the very first plugins in Kubernetes. Plugins in the sense that they were still built into the code base, but they were sort of switchable. This was the send me a PR mode. This happened pre 1.0. The networking interface happened a little bit later. Okay, so container storage interface, CSI, it's a gRPC interface. It's not an exec plugin, it's a different set of plugins. We learned a few things about exec and how it's difficult for users to manage and to install. And so we decided we're going to try something different. We use gRPC. This is nice because it allows it to run in any environment. All I care about is that I have a TCP/IP endpoint that I can reach. I don't care how it got there. So you can actually run the driver through the system. Most people will now run their CSI drivers as Kubernetes jobs, which I thought was a pretty cool trick. And it's about to go 1.0, in fact, I think like tomorrow. So excellent news there. It should go into Kubernetes 1.13 and have, I think it's beta 1.13. The spec will go 1.0 implementation beta. The goal is to take all of those 15-ish drivers that we have in tree and move them out, or most of them, into CSI plugin and kick all that code out of Kubernetes. right? There's no reason that Kubernetes in 2019 should have the word Google linked into it. It's just not appropriate anymore. We need to kick all these things out and make them deployed. Or Amazon or Microsoft or anything. So more recently than storage, we've been talking about devices. GPUs is the canonical example of what we want to do here. Anybody doing ML work? Just a few, yeah. So using GPUs turns out to be a really important thing for modern software development. A lot of people really want to do their AI and ML. They want a system like Kubernetes to run their workloads. But we need to be able to plug into the GPUs and the other accelerators that we've got in the systems. So we have these device plugins. They don't get an acronym, I don't know why. But these device plugins operate as part of the larger Kubernetes resource model. So if you've scheduled a Kubernetes pod before and you've said CPU 1, memory 256 M, you can now ask for NVIDIA GPUs in the same space, which is pretty neat. Now the scheduler will look out at all the machines in the cluster. It'll figure out who has an NVIDIA GPU. Well, you do. Well, I'll schedule one for you. Really nice, very powerful system. It's also a gRPC plugin, so it's building on the same message that CSI is building on, gRPC. Right now we've been focused almost exclusively on GPUs and other sort of similar ML accelerators, but the device plugin is actually generic. It can be used for other types of devices as soon as those things come along. So if you have an interesting piece of hardware that you want to make work in Kubernetes, I'd love to hear about it. Moving up the stack a little bit, we can talk about container runtime. So Kubernetes, when it first started, was very, very highly coupled to Docker. In fact, Docker is sort of what kicked off this whole revolution, right? So Kubernetes was built around Docker, and the code that was used to configure Docker was sprinkled all over the code base. It was everywhere. Couldn't find a file that didn't link something from Docker. And it was sort of a mess when we started thinking about what happens if we don't want to use Docker? There's all these other runtimes coming out. We had Rocket that was coming out a few years ago. How would Kubernetes use Rocket? And we started to tease apart and refactor all of that code so that the Docker code itself was encapsulated in a single package. And what we ended up with was actually a fairly decent plugin interface. So that we can now replace this Docker module with a Rocket module, or as the space has evolved, with a container module or a cryo module. Question?
How stable is it?
How stable is the interface?
Yeah, well, because normally when I hear anybody run Docker.
Yeah, so the interface is completely stable. The interface itself hasn't changed in significant ways in a number of releases. I think it's still actually designated as beta just at the API level. We're shipping it. The back-end implementations is a different question. We are now trialing a containerd implementation. I think you can get that in the GKE alpha clusters. Red Hat is shipping their OpenShift with cryo, I think, in the next release. So it's stable. It works. It's not a very complicated interface. What's cool here, though, is now we can do things that aren't sort of traditional containers, right? So I would call them sort of container-ish in runtimes. That's containerd and Docker and cryo. We now have VM-ish runtimes, which run stronger encapsulation formats that actually sort of give you a VM-like thing that runs your container. These are examples like Kata containers, which used to be called Clear containers, Hyper.sh, and gvisor, which is Google's attempt here, are all sort of closer to a VM than they are to a traditional container. You're going to trade off security for maybe performance or security for heavyweight runtimes, but this is now a trade-off that you can make as a cluster administrator by just switching out the container runtime interface. So the container runtime interface, CRI, is also a gRPC-based interface. It is, like I said, it's beta as of Kubernetes 1.9, I think it went beta. It's been in beta since, but it's been pretty stable. So the net result of this was we actually got a much better code base out of this. We found a ton of bugs in the Docker code as we refactored it out, and now we have this new plugin. Yeah.
I have a question. Can you mix the containers? Can you mix the container runtimes in one cluster?
The question, can you mix container runtimes in one cluster? Yes, absolutely. We currently only support one runtime per VM or per node. Although we're even starting to question that because we've now got this idea of sandbox containers, which is propagating through the community. So maybe it will be possible to have 2 runtimes per VM per node. But yeah, you can totally have different nodes with different runtimes, and you can use node labels and admission control policies, which we'll talk about in a little bit, to decide, maybe I trust the users from this department to run on VM, and I don't trust users from this other department, so they have to run with extra security. Right? It's a pretty cool trick. So some lessons that we learned through doing all these plugins. It's really powerful to have your plugins be running in your cluster, right? The early stuff in the CNI, for example, to get the plugin onto the machine, you have to copy a file into a directory in the host path where it can be executed by kubelet, and that was a little bit clunky, and it was really hard for people who have these sort of super locked down Linux distributions where nothing is writable, and the places that are writable aren't executable. That proved to be a bit of a challenge. So we're moving from exec to RPC. We're running them as daemon sets so that you can actually get better control of your system. We've tightened up our specifications. The initial spec around CNI was pretty loose. Over time, it's gotten a little bit tighter. CSI is a much more rigorously defined specification. And being able to run your plugins as containers is a huge win. It made it really easy for people to deploy and manage their containers, their plugins. We love gRPC now. We've loved it forever, but we love it even more now. We've got all these networking interfaces, or these plugin interfaces. And in fact, we've now got a proposal to take networking and move it into an RPC-based plugin too. So that's probably going to happen at some point. Question?
So you have the storage, networking, and the runtime plugins. What are some of the disadvantages you observe of removing all these from the table?
So what are the disadvantages of removing them from the code base? We have a little less confidence in exactly what users are going to get. Right? The trade-off of taking myself out of the loop is I'm no longer reviewing all of that code. I no longer have a sense of what users are doing, what vendors are doing. This is sort of the binary driver versus open source driver conflict that's been basically forever. When you let vendors produce binaries, you're going to get vendory binaries. You can interpret that how you like. But I'm a little bit worried that there's going to be a trade-off of quality versus this velocity. So far, it's been okay. We haven't seen any real problems with this, but it's something I'm concerned about. Beyond that, I've seen very few downsides for moving these things out. Right? Another thing that we're moving out is cloud providers. And I want to talk about the pattern for cloud providers. I just saw a question earlier.
Shouldn't the conformance test of Kubernetes touch all the paths implementation of those interfaces?
So should conformance catch these bugs? Conformance is going to catch behavioral issues, like are you compatible with the Kubernetes specification, but it's not going to catch things that are particular to a specific implementation. Like I can't make conformance test NFS, because not everybody's going to have NFS. It's not a requirement that you have NFS. So if there's some weird facet of NFS that a particular vendor is shipping, I'm never going to see that in conformance, because it doesn't manifest at the Kubernetes API. There was another question over here. No? All right.
You mentioned that there are some plans to move the basic networkings of pods out to a separate plugin. Did I understand that correctly? So would it follow that the standard way Kubernetes does networking with services, port forwarding, etc. would be some kind of optional? Because as I know, Malta's CNI made by Intel sort of sideloads actual interfaces with Ethernet into pods. So if base networking would be a plugin, would it be optional in some way?
That's a great question. Strictly speaking, services are already optional. They're not actually required to run the cluster. There are some things that probably just won't work very well without them. They're not actually required. So in the strictest sense, kubeproxy itself is a plugin. And in fact, that'll cover in the next session. But you have to do something for networking. The rule for Kubernetes is that pods have to have IP addresses and pods have to be reachable by other pods. How you choose to satisfy that is entirely within the networking space. So examples of the things that I've seen people do with CNI, some are using straight up encapsulation, right? Some are using just L2 route programming, IP route nav. Some are using BGP. Some are using programming other out of system fabrics like Google Cloud. And others are doing other tricks with kernel drivers that present phony interfaces that map to other ports on the real VM's IP address. So I've seen pretty much every implementation. You just have to have something, right? That's the only rule.
So in theory, I could, because currently if I use Maltese to have multiple interfaces, I still need to have the base Kubernetes standard network interface as the first interface on a pod. So in theory, in the future, I could skip the standard Kubernetes interface as long as Maltese provides enough of connectivity for the Kubernetes to cluster to talk to the pod, right?
It's a bit of a trick question because there's no standard Kubernetes interface. There's a default, but you can use Maltese to totally replace the default. You don't need to use the bridge driver. You don't need to use the PDP driver. You can totally replace it with something else if you want. Maltese is a way of getting multiple interfaces into container pods, which we may standardize further yet. But as long as one of those interfaces is satisfying the main Kubernetes requirement, that's all we need. Usually it's the first one. So we've talked about plugins, which are really synchronous plugins, right? Kubelet makes a call out to the storage driver mounts the volume, and the volume returns. We have a different pattern of drivers that we use, a different pattern of plugins that we use throughout the clusters, which is controllers. Have you heard the term controllers before? Yes? No? Basically, it's a loop piece of code that looks at something, observes the state of it, looks at what it's supposed to be, calculates a difference, and then acts on that difference to try to drive the real state towards the desired state. Examples of controllers. Now this is the most important design pattern in Kubernetes. It's basically how everything's written. The examples here are things like the scheduler. The scheduler looks at a pod and sees that it is not scheduled, but it wants to be scheduled, so we'll try to schedule it. Kubelet looks at a pod that says it wants to be running, but it's not running. Let me go try to run it. Deployments say you expect to have 5 copies. I only found 2 copies. I'm going to go run 3 more. Proxy looks at services and says you expect to have a virtual IP, but you don't. Let me go create one for you, etc. So one of the more interesting plugins that we're talking about now is cloud providers. When you run Kubernetes on Amazon, you run Kubernetes on Google, you run Kubernetes on OpenStack, you have to have something that is adapting Kubernetes to your cloud environment. That means getting information about the nodes and programming the node objects. It means maybe going out and programming the network or doing IP allocations or creating storage devices. All of these things are currently linked into Kubernetes. So we've got a directory in Kubernetes that has about 8 cloud providers in there, which total up several 100,000 lines of code. And people keep sending us pull requests. Hey, I want to add my cloud provider to Kubernetes. There's just no way we can handle this. It's like a third of the code base. So we're moving cloud providers out of the tree. Remember earlier I said there's no reason that Google should be mentioned anymore inside Kubernetes. We're going to kick all the cloud providers out into separate controllers. They're just going to run as a separate controller that runs asynchronous to everything else, and they're going to observe the state of everything in the API server, and they're going to react just like they do today, except they won't be linked in, they'll be in their own plugins. What's cool here is now you can have your cloud provider who isn't in the code base give you a binary that can run Kubernetes on their cluster. So, for example, a bunch of cloud providers that are using the externalized API already, things like Alibaba, things like DigitalOcean, are building completely out of tree. OpenStack has volunteered to be the first in-tree plugin to move out of tree. So we're setting that up for the next couple of releases. They're going to start deleting their own code. And they're just implemented as controllers. And I'll talk a little bit more about controllers in a little bit, about the other things that you can do with controllers. So I mentioned services, right? Services is really an abstraction. It's really an optional plugin. The only thing that a service is really a VIP. And anything that you can use to create a virtual IP can actually act as services. So there are Kubernetes installations out there that don't run kubeproxy at all. They run something else that programs their network fabric to have a virtual IP, which ends up routing the traffic instead of a IP table. So totally valid thing to do. It is really an extensibility point that sort of is under-recognized. So there's a whole bunch more, but I want to switch to the other topic now. Other things that are plug-inable, right? Secret management, we have an RPC interface for auth stuff. We have ingress for load balancing. DNS is a pluggable interface. You can replace our DNS server with any other DNS server you like, etc. So these are just the boring parts. These are the parts that are sort of below Kubernetes. Let's talk about the parts that you build on top of Kubernetes. This is the API extensibility topic. So what does API extensibility really mean? It means you can take our Kubernetes system and you can add your own types to it, right? If you want to add a type that represents something that's part of your business domain, you can do that. If you want to take a type and build your own kind of deployment, and you don't like the way Kubernetes deployments work, you want to build your own, you can totally do that, and you can build your own custom logic into Kubernetes that does deployment the way you want to do that, right? This lets you build in these new types without recompiling Kubernetes. They're just dynamically loaded into the API, which I think is just super cool. And the result is that you get things that actually feel like they're built in. You can't actually tell the difference between the ones that are defined as custom resources and the ones that are just built in. Additionally, you can add policy hooks. Right? You can add these things we call admission controllers, and through these policy hooks, you can change any behavior of the system. Right? You can apply arbitrary policy to plugin or to objects as they come into your API. Policy is absolutely arbitrary. We used to think that we could define very tightly controlled policy hooks for everything that people would want to do with Kubernetes. It turns out that was a fool's errand. Everything that could possibly want to be policied, somebody wants to policy. So we added it more as an extension API. Basically what you get here now is APIs that modify the API. It's an API. So there's different levels of customization that we offer through our API. Different users have different needs. We have two main ways of doing it. One is called custom resource definitions, which I mentioned, and the other is called an extension API server. Both let you create new types in the API server. Both are not really limited in their capabilities of defining new types. One extension API service gives you a little bit more power and flexibility, but it's a little bit harder to use. So this is the trade-off we make. I'll talk about the details of that in just a minute. But like I said, you can do your own workload patterns, which is a really common thing that we see people doing. You can also define higher level abstractions where you want to hide some of the details from your users. Basically, you build yourself a platform as a service, custom paths for your company, and build it on top of Kubernetes. But you can also build entirely new concepts. You don't have to build Kubernetes stuff, which I also mentioned, Istio. Istio happens to be built as custom resource definitions on top of Kubernetes. So you can use the Kubernetes API server as your Istio API server, which is a pretty cool trick. Other things that build on top of these extension mechanisms, Knative. You've heard about Knative. It's a set of tools for building platform as a service components. The Kubernetes metrics API server, if you've ever used a horizontal pod autoscaler, it uses extension API server to be able to pull metrics from our backends like Stackdriver or Google. And we've heard the term operators, right? Sort of a generic term. We'll talk a little bit about it, but basically it means I'm defining a custom type, I'm defining custom actuators for that type, and I can do anything I want. The classic example is a MySQL operator. I want to create MySQL databases, but I don't want to know anything about how to operate them, so I'm going to write a robot that helps manage my MySQL operators. Now I have to say qcode create MySQL, and ta-da, I've got a MySQL database. Another example that I'm going to dig into right here is Docker Stats. Have you ever used Docker Compose? Right? A lot of hands there. Docker Compose is a really nice, simple interface, right? It hides a lot of the details from you. One of the things Kubernetes gets charged with a lot is too much YAML, right? And there's a lot going on in our YAML. Docker Compose is a really nice, simple YAML interface. So here's an example of the Docker Compose file, right? I think if this was Kubernetes, I'd have to make it like a 2-point font so it fits. So this is a really simple example that just runs one container. So now if I want to deploy it, I've just got a single command line. I say docker stack deploy, and it goes off. You're calling it stack demo here. And it goes off and it runs it in your Docker Swarm, and you're done, right? Really nice. Did you guys know that Docker is built on top of Kubernetes now? Anybody know that? This was, as of last year, Docker Enterprise Edition has a Kubernetes mode, and it can basically operate as a plugin on top of Kubernetes. So if I say kubectl config, I'm going to change my, take a look at my current context. This was all run on a Mac using Docker for Mac. So I run kubectl get services, and I can suddenly see that I created my Redis service from my Docker Compose is actually running in my Kubernetes cluster. Let's dig into exactly how that happened. Also, if I say kubectl get deployments, I can see that my Redis deployment is running. So when I ran that Docker Compose, it actually created a Kubernetes service in the deployment. What we've seen here is a pattern that we see over and over again. You take a higher level abstraction, and you convert it into a series of smaller, lower level abstractions, which the users don't have to deal with, but you can. So hypothetically, this might be how it works, right? I've got my Docker Compose, I send it off to Docker D converts my Docker Compose file into a Kubernetes service and a Kubernetes deployment. And that's cool, but it's not exciting. That's not actually how it happens at all. If you say kubectl get stacks, you can now see my stack demo. What the heck is a stack? A stack is not a Kubernetes resource. It is in fact a Docker extension API server that they are running, which is registering the type stacks. So I split my screen here. On one side, I'm just going to run kubectl proxy so you can sort of see the API transaction as it happens. And when I run kubectl get stacks, it showed me my stack demo. What you see is the API that we actually sent to our Kubernetes API server. It's at APIs compose.docker.com, v1 beta 2, namespaces default stacks. Right? That is the exact same URL pattern that we would use for deployments, or pods, or persistent volume claims, or any other Kubernetes thing. So what really happened here is I talked to Docker D. Docker D shipped off that Compose resource as a Kubernetes stack. Kubernetes stack was actuated by a controller, which then wrote out the service and deployment resources. What's neat here now is I can go in here and take a look at that registration. So when I run get API services, it's going to show me that in fact v1 beta 2.compose.docker.com was registered there. And I can go take a look at it and I can see what it would do, and it shows me that it did in fact create this API group. Right? So here you now see it in the Kubernetes cluster, and it's live. Now, what does an extension API server do? An extension API server lets you run a server, or it runs a process in your Kubernetes cluster that we forward URL requests to. So when that URL that we saw earlier comes through our Kubernetes API server, we realize, okay, that's a Docker stack. That goes over here to this other guy. Pop back. You can see here that it says service name compose API. When I say services, I see my compose API. So our Kubernetes API server forwarded that URL and all the payload onto your API server. The Docker stack API server responded to it however it needed to respond to it. It did validation and it checked it in and said, okay, looks good to me. It checks that into etcd and now gets actuated. Now you can see it here that it's running both as a service and a deployment. So I think that's really neat. I think it's kind of cool that nobody ever noticed that Docker Compose changed underneath it. Right? It just kept working. Docker was able to keep their higher level of abstraction, but they were able to start building on top of a system like Kubernetes that has a lot more flexibility and power that they can use, and their users never felt it, which I think is great. This means for you guys, if you're running, you're the IT person at your company, and you want to build a higher level of abstraction, you want to insulate your developers from the details of the infrastructure, you can build your own abstractions that map to how you want to run your company, or your IT department, or your service. So what's the difference between an extension API and a CRD? Extension API server is you're going to write and run your own API server. We're going to forward those requests on to you. It's kind of nice because you can write code that does arbitrary validation. You can go out and Google search the arguments and make sure that they're present, or whatever you need to do to validate those arguments. It's arbitrary, and it's all built in. CRD, on the other hand, is really just a schema. You give us a schema file. Actually, we don't even have to give us a schema file. We can run without schema. Our main API server is not going to store those resources for you. We're not going to do any validation for you. Well, actually, we will, because you gave us a schema. So we're going to do some basic JSON schema validation, right? But it's fairly limited in its capabilities. If you want to do validation and defaulting and those sorts of things, you have to do it through a second step through the mission control. So a custom resource definition, you literally fork nothing. You write a YAML file, and that's all you need to do. An extension API server, you're going to fork about 5,000 lines of Kubernetes code. You're going to use that as a basis to start your API server. Storage in a CRD is built in. You get our storage for free. Extension API server, you have to run the storage yourself. Likewise, there's a couple of different components to run. If you look around at GitHub and see what people are doing with extensions, you'll find on the order of 10 to 20 extension API server projects like Docker. If you look at CRDs, you will find hundreds. The last time we looked, we found over 500 different CRD-based projects on GitHub. And that was just looking for the obvious things. So popularity of CRD is obviously much, much higher because it's much simpler. Now, if you look at the rest of our ecosystem, we talked about devices and storage and networking. All of these gRPC-based interfaces, these infrastructure plugins, they're in the order of 10 to 20 plugins that you can find each. These custom APIs are just through the roof. It's amazing what people are trying to do with these CRDs. So I've mentioned a couple times admission control and webhooks. What is admission control webhook? Admission is the cycle of our API that happens after you've authenticated a request that's coming in and you've been authorized to do the thing that you're asking to do, but before we actually store the change. It's only affected on writes, on reads don't pass through admission control. And since it's a webhook, we call out to your service. So you provide something somewhere that is running a URL, and we're going to call out, we're going to pass you the contents of an object, you're going to do what you're going to do to it, and you're going to return. We have two different kinds of webhooks. We have mutating webhooks, which lets you go out and change the values that are in the object. So this is where you can set default values, right? If the user didn't specify the depth field, you can set the depth to 6. And then we have the validating hooks, which validate that everything the user gave you is valid and correct and is acceptable to your API. If it's not, you return false, and we will reject the transaction synchronously, and the user will get an error from the kubectl command line, just like they would for building time, right? Both of these are really simple to run. There's an example that Kelsey wrote. Kelsey gets 2 mentions today. Kelsey wrote a really simple example using Google Cloud Functions that lets you do a validating hook just through a little bit of JSON, JavaScript.
My question: what happens if, for example, like admission web controller is down, and what happens to the objects? For example, I have admission hook that adds me a limit to my collective defaults, and what happens to the defaults if there is no, if it's down?
So if you have a webhook that's registered and I can't reach the webhook, it will eventually time out. It will time out, it's got a 5-second timeout or something, and then it will just cancel your transaction. So I'm sorry, you can't do the thing you're trying to do because I can't reach the validator. So don't write bad webhooks. You can cause a lot of trouble. Also, don't register webhooks on things like pods unless you really know what you're doing, because you can cause a lot of churn on the system. So there's some good things and some bad things about webhooks. Remember, they are synchronous, so however long you take is how long your users are waiting. So this allows, webhooks allow you as a CRD author, you can add any arbitrary validation logic that you want. Right? You can check that it's Tuesday, you can allow operations on Tuesdays, whatever rules you need to apply, you can apply. And if you're a cluster administrator, this is the super cool part, you can apply arbitrary company policy. You can say, you know what, we don't allow pods that use environment variables. I don't know why you want to do that, but this is the example that Kelsey wrote, right? And so you can apply an admission control webhook on pods, even though I just said don't. You can do that, and you can reject pods synchronously so that users cannot do the thing that you don't want them to do. This is really useful for things like checking security policies, checking for PII, checking for things that you know that your users aren't supposed to do. And again, policy is just arbitrary. We talk to enough customers every day that we realize there's just no way we can build hard rules for all these things. So examples of what people are doing with mutating webhooks that are even more than just changing defaults. Looking at the Istio project. What Istio does is every time you submit a pod, it's going to add a container into your pod. And that container is running the sidecar proxy that drives Istio. As an end user, you don't know that you're running Istio. It's kind of neat. The sidecar traps all the traffic that's leaving the pod, and I don't have to know anything about it. Right? It's completely transparent to me. Another example is Service Catalog, which is used to inject credentials for services that you're being bound to dynamically. Another one is something that we're working on now called Vertical Pod Autoscaler, which will try to set the sizing requests for your pods automatically. So it'll look at the history of what pods have been doing, and it will try to guess how much memory and CPU you're actually running. And it sets that dynamically at startup time. So I'm going to wrap up. Kubernetes, we're taking extensibility really seriously. We've spent an enormous amount of engineering time on extensibility and related topics over the last couple of years. It's going to continue to be a very big topic. Talking about this some more at KubeCon. We've got a ton of presentations at KubeCon, people talking about operators that they've built and extension API servers and crazy things that they're doing with these extension mechanisms. We want you to extend Kubernetes. It turns out it's a great platform for building your own thing, so please go off and build your own thing and blog about it, because I want to read things we work with. Any other questions?
So, with managed Kubernetes systems that, for example, various cloud providers provide right now, there's one from AWS, there's one from Azure. It's easy to scale the Kubernetes cluster, add nodes, remove nodes. But what if we have a Kubernetes on in an environment that does not provide such capability? How would you solve? Would you create some sort of controller inside Kubernetes that would call to underlying infrastructure? Would you implement all the logic there, or would you use some sort of configuration management tool like PuppetJet or whatever to talk to underlying system?
Why not both? When you talk about a cluster that can scale, we're talking about the cluster autoscaler project. But the cluster autoscaler project is really nothing more than a controller that watches all pods and says, hey, that one's not scheduling. The scheduler has marked that one as not feasible right now because there's no resources available in my cluster. What should I do if I see that? Well, we happen to know that if you're running on Amazon or Google or Azure, you know how to reach out into the infrastructure and say, go make us a new node, right? You could do your own. You can either take the cluster scaler project and fork it and add your own changes, or you could write your own controller that goes to the Dell website, buys a new machine, and has it shipped overnight. Right? Yep.
So, this cluster API, secret cluster API that writes implementation of machine deployments, provision, CRD for machine deployments.
Another great example is the cluster API, which is using CRDs to build a generic API for provisioning machines, which we can then code against Google, or you can code against OpenStack, or you can code against your ticket system.
All right, so that was pretty good. That was a lot of fun. We learned a lot, and that was ended a little early because we were expecting a Q&A, but that's fine. I think.
I'm sorry.
Yeah.
If we have more questions that are not related to that, I'm happy to field those too. You want to ask me about the future of Kubernetes, or the history of Kubernetes, or what color my socks are?
So do we have any other questions at all for Tim?
Yeah. What's the future of Kubernetes?
Good question. What is the future of Kubernetes? World domination. It's amazing to be here in Warsaw, talking to a room full of people who heard about this little software project that I work on. First I want to say thank you, because it's just overwhelming to be across the world talking to people who are excited about the stuff that we did. I barely know how to handle it. What is the future of Kubernetes? More, bigger, faster. We're going to scale more. We're going to scale better. We're going to handle more environments. The extensibility systems are going to get more robust. I'd like to paint a picture in the future where everything is a custom resource, where all the built-in types get kicked out, and they're defined as custom resources. That's how we know when we're done with the extensibility system. We'll see more and more cloud providers getting support for Kubernetes. We're going to see higher levels of abstraction. We think things like Istio, I think, are game changers. They do things that are sort of outside the box for what Kubernetes itself will do, but really bring a ton of value to end users. I think also we're going to see Kubernetes slow down. We're already starting to see it slow down. The rate of change to the Kubernetes repositories is slowing down a little bit. Although it's getting broader, it's a little harder to measure. The ecosystem's more than just one repository now. But we're seeing the rate of change of things like the APIs are starting to slow down. As the extension mechanisms kick in and more people are able to do things out of the project, we're encouraging people to do that, right? 3 years ago, Istio was not possible. It would have had to have been something built in, right? Or Knative or any of these other extensions. And now they're not built in, so they're happening outside the project. And that's good. The more we can take things up level, the better off end user. The highest level of abstraction you can use is the best one. So I think people will continue to build up and up and up until at some point Kubernetes is just a thing that is an implementation detail of the way you build something. Right? The way most people assume that you've got Linux available somewhere, you just assume that you've got Kubernetes available somewhere. Ideally, people come out of university having built complicated distributed systems as computer science 101 classes because Kubernetes was just there to help them do that. So.
Any other questions for Tim?
I have a Kubernetes
Okay.
question that's not related to today's talk.
Sure.
I like your jacket. How can
Talk to the Kubernetes Warsaw team.
Oh, that's it.
They'll trade a resume for a jacket.
Just yell, maybe I don't know if we can get there in time.
No worries. So if Kubernetes is the next Linux, who is the next Red Hat?
IBM.
IBM, exactly. There's no Red Hat.
Red Hat is the next Red Hat. Red Hat is one of the biggest, most active contributors to the Kubernetes project, right? OpenShift is probably the most widely used Linux distribution, Kubernetes distribution out there right now. I'm not sure exactly if there will be a dominant enterprise player for Kubernetes. Obviously, there's a lot of people competing in that space right now. We're going through sort of an interesting time in the market where we're seeing a little bit of contraction, right? Red Hat now joining IBM and Heptio now joining VMware. It's interesting to see what's going to happen over the next couple of years. Obviously, Google is trying to play in this space too. Now announced GKE on-prem product pitch right there, which is entertaining enterprise customers with an on-premises Kubernetes solution. I expect to see much more of that. If you remember Linux in maybe 1999, 2000, there was hundreds of Linux distributions, right? And that had to happen before you get this contraction down to 5 or 6 that actually happened. So I think we'll see that.
Yeah, can you tell us more about this GKE on-prem?
Can I tell you more about GKE on-prem?
Yeah. What was the future of the project?
GKE on-premise, I don't want to make this a project, so I'll make it quick. GKE on-premise is about taking the GKE experience and bringing it to you in your data centers. We heard from customers day in and day out that they want to use Kubernetes, but they have to stay in their own data centers for legal reasons, for logistical reasons, whatever. They weren't ready to move to cloud yet, or at least not ready to move entirely to cloud. They love the GKE experience, they love the managedness of it, they love the automaticness of it. They want that, but they have to stay on their own equipment. And so GKE on-prem is our attempt to give them that environment, to bring the cloud to you, is the line.
So is it a part of some hybrid solution? Will it cooperate with GKE?
Yes, the question is it hybrid? Yes, it's absolutely hybrid. The way you access and control your clusters is through the Google Cloud Console, where the clusters register to the Cloud Console. So you see it right next to your GKE clusters. You can apply the same configuration and policies to those things in your single Cloud Console. So you get your single pane of glass view of control. You run a connection program that will connect to Google and let us feedback control into your cluster. But otherwise it runs in your premises. So if you lose your connection, if your internet goes down, your clusters are still fine. You're going to run everything in your data center. you don't need to transmit your data over the internet or anything, but you still got the Google managed experience. That's if you want to talk more about on-prem, I'm happy to talk about it offline. I don't want to make this a product.
Just a question over there.
I have a question. If you could not use Kubernetes or Metis, what would you use?
If I could not use Kubernetes or
What is
Metis,
out there? What is there, like, do you see something new emerging that is like, these guys, I should observe. They might come up with something better or different? I don't know. Unikernels, there's like a lot happening.
it's sort of a tricky question. When I, a few years back, when I was working in the board team here at Google, a sort of thought crossed my mind one day. I was like, one day I'm going to leave Google and I'm not going to have all of this. That's going to suck. So if I didn't have Kubernetes and I didn't have Mesos, you took the two biggest players off the table. I think the stuff that Hashi's been doing, Nomad and their whole Hashi suite, is really nice. They make great products. It's a little simple for some of the larger use cases, but people who use Hashi products love Hashi products. So I think that's really interesting. Docker, with Swarm, although it's sort of not been in the news so much lately, it's a really nice, simple system to use. Right? I don't think it would replace Borg, but it's a nice system to use. At some point, we did a survey of orchestration systems that people were using, and sort of it was Kubernetes by a mile, and the top competitor to Kubernetes was shell scripts. So probably if I wasn't using Kubernetes, it would be shell.
How do you perceive the development of federation functionality and multi-cloud deployment? Is it going to be more popular right now across enterprises?
Federation and multi-cloud. I think federation, sort of with a capital F, the project federation, is not going very far right now. I don't think the model holds too well, but the idea of using multiple clusters and using them together, I think everybody will do this at some point. It doesn't make sense to have everything in one cluster. You don't put all your eggs in one basket. People are going to want to have multiple clusters in multiple geographies, whether that's for latency or security or jurisdiction reasons. The bigger companies are all about multi-cloud. They want to have assurances that no matter what happens, they've got some backup plans, whether that's live multi-cloud or disaster recovery or offline backups. We see this with every customer larger than the planet. So yes, I think absolutely people will do that. The way we're approaching multi-cluster now is much more in a solution-oriented way instead of an architecturally oriented way. We're looking at the problems people actually have and trying to solve those actual problems. So GKE on-prem comes with this idea of the GKE hub, which lets you view all your clusters. You'll be able to apply policy across them together. Because one of the things we keep hearing is I want to apply consistent policy across my clusters. Okay, cool, we can solve that. Another thing we keep hearing is I would like to do load balancing across my clusters. I've got a cluster in Europe, a cluster in Asia, a cluster in America, and I want to run the same application and I want people to hit the one that's closest to them. Conveniently, that's something that Google Cloud does really, really well. And so now you can expose that through the multi-cluster ingress tool, and we'll be adding more to those interfaces as things go on. So we're trying to approach it from a very pragmatic point.
Okay, that's it for questions.
I'm happy to hang around and do more
Do
questions.
you want to take any more?
Sorry, he did have his hand up earlier.
Are we good with questions, or do you want to take any more?
I have a question.
One more? Okay, one more. Go ahead.
I know that there is no simple definition, there is no simple answer, but I have different definitions, and I would like to hear your opinion on that. How exactly huge the microservices should be? Like, it should be a functionality or a group of functionalities?
And how big should a microservice be? It should be as big as you're willing to carve into a separate chunk. There's no real answer to it. There's microservices and there are monolithic microservices. And there's not really a recipe for how to do this. Instead, I'll turn around and say these are the things you think about when you're talking about a microservice. What are you going to version and test as one unit versus what are you going to version and test as an API, right? It often makes sense to fracture your microservices along sort of business units or teams because those teams can then operate without coordinating with each other. Right? You can build strong tests against APIs instead of monolithic things. That's usually the biggest thing that we hear when we talk to people about microservices is the testing matrix that you're going to have to do between all these things. But you also have to think about failure domains, right? If you build a big monolithic microservice and he introduces a bug in your code, are you okay with your service crashing, right? And certainly at Google we have flavors of this, things like the projects, but I don't know what's public and what's not. But certainly we have services that are checked in from code from dozens and dozens of different teams, and they deploy together. And if any one of them messes up, they all crash. And it's totally uncool unless you have really good testing. And we've got the other extreme where we've got really tiny microservices that just do one thing. They have one RPC interface, and that's it. And that's also okay. So there's not really a hard answer to this. It depends on your environment, your business, your code, your languages, etc.
More questions? There we go.
Yeah, more. Can you tell, are you aware of any ML projects that are using Kubernetes? Can you tell something more about kind of advantages? And how do you see kind of future of ML in Kubernetes? Is it kind of gaining popularity, or do you think it will fade away?
So ML projects that use Kubernetes, it's hard to keep track of what's public information, what's not. We have Cloud ML Engine, which is built on top of Kubernetes. We definitely hear ML every day. There are customers who are using ML, so I would definitely say it's on the upswing. This is why we're building projects like Kubeflow, which tie together a bunch of the best in-breed ML projects, bring them together on top of Kubernetes, and make it easy for you to run your ML projects in there. I'm not going to name customers because I can't remember what's public and what's not, but there are some big customers that are doing ML stuff, AI stuff, that if you ever come to California, you've seen billboards for, that are doing it on top of Kubernetes.
Right there.
Do you predict Kubernetes to replace Borg?
Kubernetes to replace Borg. Borg does like 8,000 things. And it co-evolved with search and ads and Gmail. So it has a ton of features that are built just for those systems that don't make any sense for Kubernetes in general to adopt. Maybe one day, it's not a goal right now. It is a goal to steal Borg's users, right? I could imagine an end game at Google where Borg has 10 users and everybody else runs on top of Kubernetes. Right? I could live with that. But I don't know that Kubernetes will ever fit the needs for search. Search is a really particular application that 4/9 of people will never need those features. And so I don't know that Kubernetes will want to adopt that complexity to service those features. But we're open to it too. If other people come to us and say they need these features, then we're going to listen.
Any other questions? We invite you, of course. Yeah, sir.
So you mentioned that the controller pattern was kind of design pattern is the main kind of pattern in the Kubernetes. Was it kind of from the beginning of the Kubernetes, or you kind of realized in the process of creating Kubernetes that it is something that you should follow? And the following question: are there any kind of design patterns that you also have in the Kubernetes and you should mention it?
So controller pattern, it was absolutely intentional. Some of the earliest folks on Kubernetes had backgrounds in control theory, and so they wanted to model how you build a robot. Right? How you build a robot? You build a sensor, and you take feedback from the sensor, and you act on the feedback, and you just build something. Right? So it was definitely intentional. The details of it sort of evolved over time. We sort of figured out what the sort of purest way to do it was, and that informed how we designed our API and how we built systems like the Watch API. Are all built around the idea that if you build these sort of pure, stateless or nearly stateless controllers, then software is much easier to manage. You can scale it much better. It's easy to reason about. The code is actually very straightforward to read when you look at a well-run controller. And we're able to encapsulate a bunch of the most common patterns there into libraries so that people can build decent controllers very easily. In fact, there's a cool controller that one of the guys at Google wrote called MetaController. And MetaController captures an even higher level of abstraction. When you watch an API, you can sort of do anything you want with it. But what most resources do is they take in one resource and they output some other resource or resources. So MetaController takes this a step further and it says, feed me some JavaScript. I'm going to feed you some JSON on the input. You're going to feed me some JSON on the output. And that's it. And don't worry about anything else. I'll handle all the synchronization. I'll handle the watch. I'll handle the listing and the resource versioning and the retries and everything else. And so you can write literally 20 lines of JavaScript and produce a fully functioning Kubernetes controller.
Any other questions? If not, we're going to wrap up the QA session. Okay. Any questions? This is the last chance here.
Why JavaScript? Why?
Because you can't find a simpler example than JavaScript. You can do a lot of stuff in 20 lines of JavaScript, including crash. And it's a nice example that doesn't require you to compile anything, and it's very approachable by a lot of people. But MetaController can also support other languages, which just uses JavaScript as a demonstration.
Okay, was that the last question? One more? Okay.
How much nodes have the biggest Kubernetes cluster?
How many nodes the biggest Kubernetes cluster? Well, we claim to support 5,000. I've seen clusters upwards of 4,000. So I'm guessing that the answer is somewhere between 4,000 and 5,000. But most clusters don't call me, so.
But there is any reason to have multiple clusters in one organization?
Are there reasons to have multiple clusters? Absolutely. Blast radius. Sometimes you just make a bad push, or you update your Kubernetes and you do something wrong, or something goes sideways, right? Kubernetes is software and there's bugs in it, and sometimes the master crashes. And if you crash on a giant cluster, then you're going to have a very large blast radius. So some people want to set up multiple clusters to reduce blast radius. Depending on what you're doing with your cluster, it may or may not scale to 5,000 cleanly. If you're doing very intensive clusters in some dimensions, you'll reduce the scalability in other dimensions. Scalability is not a linear thing, right? So sometimes you just need multiple clusters because you need better isolation of the scalability zones. Some people do multiple clusters to emulate cloud environments so that they teach their application developers to always build against 3 clusters in 3 different zones so that they don't have failure cases. Right? So there's a lot of reasons.
Any final questions? We can have 10 more final ones. Okay. What's the recipe for the lightest Kubernetes node?
What is the recipe?
Yeah. So, could one use a Unicron?
I see. I don't know anybody who's tried any unikernel sort of things with a Kubernetes node, although it would certainly be interesting to try. No, the most common thing that we see is plain old Linux nodes. We still see a lot of people using CoreOS Container Linux. Google push this thing called COS, the Container OS, which is a Chromium-based distribution. But at the end of the day, they're all Linux. Although Windows support is coming, they're pushing hard to GA Windows support in the next release or 2, which means you'll be able to actually run a Kubernetes cluster with Windows nodes.
Anyone else? I know there's someone just can't wait to raise their hand.
So, what's your comparison between your how you imagined Kubernetes when you started it and right now?
Oh man, this Kubernetes has so wildly exceeded my expectations. I thought that it might be cool if we had some users who were willing to trust us with this thing. This has gone so much faster and deeper than I could have ever expected. Architecturally, it's pretty close to what I expected. What actually has been happening is the world has been fast forwarding through the Google history at like a much faster clip than Google did. I joked at the beginning of Kubernetes that we had a crystal ball and we could predict the future because we already lived it. And so far we've been pretty accurate, not completely, but pretty accurate. But the world is going through Google's 14 years of history in about 5 years. And that's fantastic, but it means we're also entering spaces where we don't have answers anymore. We're trying new things out, or where the answers we do have don't fit. So we're sort of getting to the really interesting part now. I also like to joke that the easy part of the project is well behind us. We're way into the hardest part now. I've been at Google for 14 and a half years.
With CNI and CSI and everything as a plugin, what will you actually distribute? What will you take ownership of? Because if there are multiple projects that provide CNI plugins or CSI plugins, will there be a standard Kubernetes-based distribution or something eventually?
That's a great question. I gave a talk at KubeCon last year, 2 years ago, year and a half, something like that, where I asked the same question. What are we going to do when cloud providers are all out of tree? Kubernetes won't run anywhere anymore. I think we'll always have some environment that we run in out of the box. So there will always be an out-of-the-box network driver. There'll always be an out-of-the-box environment driver that might not be a cloud anymore. It might be local VMs, virtual boxes, what we're trying to come up with. It might be built in VirtualBox, or it might be Minikube, or it might be Docker and Docker, or some environment that you'll be able to run the tests and try out Kubernetes and do things with it. But you may need to get third-party drivers to actually do the things that you want to do. Likewise, we'll probably always bundle the sort of standards-based drivers for storage, things like NFS. Like we'll probably have an NFS driver because there's nothing really vendory about NFS. And if you want a vendor NFS, you can do that too. But we'll ship sort of a standard NFS driver. We'll ship standard mount a local block device driver. Those sorts of simple things. But you're right. More and more things are going to move out, and you're going to have to. Somebody will have to assemble a distribution. Whether that's going to be us, the community, or whether it's going to be some new Red Hat, or whether it's going to be you, the end user, I think remains to be seen. I'm personally sort of in favor of us putting together a community open source based distribution that other people can use as a building point for other distributions. But it's a lot of work, and building community around projects like that is really hard. So we'll see how that goes.
How do you write GitHub for managing such a large project and community? Is it still okay for you, or are you considering moving somewhere else?
We've been bumping our head against GitHub for a long time. GitHub's an amazing site, and the service they provide us for free is incredible. We are really pushing them to their limits. It's not a great experience for high collaboration. GitHub issues are not, it's not the best issue system in the world, it's not the best code review system in the world. But by and large, it's good enough. And especially in the last 2 years, they've really made a lot of improvements, especially around code reviews, that have taken them from, oh my god, this is painful, to, okay, I can do this, right? I wish that I could convince them to do all the things that I need them to do, but I recognize that Kubernetes is like the 99.9999th percentile of their users, and so it doesn't really make sense to spend a lot of engineering time tailoring their system for what nobody else is going to use, right? It's not terrible. There are places where it can improve. We talk to them on a fairly regular basis. Also, they run Kubernetes, so every time GitHub has an outage or something, it's please don't do that. And honestly, like, could I fix Kubernetes if GitHub was down?
There we go.
Is there on the plan to release LTS version of Kubernetes?
I would not say there's a plan. There's a working group that is trying to form right now to figure out if and how to do that. There's some dissenting opinions about whether LTS is the right thing to be building, or whether we should actually be focusing on stability of the project and lowering the risk between versions, including ideas like, what if we cut a release every week? Then the delta would be much smaller, right? The risk would be much lower. And if we decided to scrap 1 week, it wouldn't be such a big deal. All the way to the LTS approach, where we would cut a release once a year and people would stay with that one release, right? There's lots of different philosophies and theories of software engineering here, and everybody's had different experiences with release engineering and these sorts of problems. So it's going to be an interesting discussion, to be sure. I do not know what's going to happen.
Anyone else?
Yes. What's your role in work as project now?
My role in the Kubernetes project is, it's a great question. I'm not on steering anymore. I guess I would say like town elder.
What was the craziest thing you heard of?
Craziest thing that I've heard of. That I accepted or that I shot down?
Oh.
I mean, some of the crazy things that people are doing, like I like to pick on Istio because I think they're doing really crazy stuff. The sidecar injection is mutating webhooks sort of to an extreme level. They've got some new ideas that are plugging in and trying to plug in at the network level. They're trying to mutate CNI drivers and maybe even act as a CNI driver. I'm not sure it's a good idea, but it's certainly interesting. And so we're trying to figure out how or if to make that work. On the things we've accepted side, it's hard to come up with a single example. There's been plenty of cases of things that I've seen and said, oh God, I hate that, approved. Because I don't have a better answer or because I understand the problem that people are doing.
Okay, well, thank you guys for coming down, and have a good rest of the day. Hope you join us at the closing party.